Hi all, good evening. Welcome back to Manorama Horizon. Hope you all doing well. Okay, so today we are going to study. We are going to revise our first chapter, real numbers. Okay, so hi all. Okay, so today is a revision class on your first chapter, real numbers. Am I audible? Am I audible? Okay. Okay, Aparna. Okay. So let's start. So this is our first chapter, real numbers. And comparing to the other chapters, this is a simple chapter. And this covers only very simple topics. All concepts covered in this chapter is very simple. You can easily understand all topics covered in this chapter. Okay. So today we are going to recollect some basic ideas of real numbers, and we have to recall the fundamental theorem of arithmetic, and finally we have to revisit irrational numbers, and we have to practice some questions from the chapter. Okay, so what do you remember? What is real number? We can simply say that real numbers are the numbers that can be represented on a number line. Is it? There is numbers that can be represented on a number line. That is real number, simply. Okay. So what are the numbers that included in the number line? So basically we can say that are rational numbers and irrational numbers. Okay. So what are the numbers included in the rational numbers? So from base, the first type, that is natural numbers. We all know what is natural numbers. Simply we can say that is counting numbers. 1, 2, 3, 4. Counting numbers. That is natural numbers. Simple. Is it? So if we included a 0 with this natural number, we get whole numbers. Okay. We added a 0 with this natural number, we get whole numbers. Okay. If we included some negative numbers to this natural number, then we can call it as integers. Okay. So we can call it as integers. So that is integers. That integers included negative numbers with this whole number. Okay. And if we represent this integers as in P by Q form. What is P by Q form? That is fraction, right? So if we represent this integers as in fraction or in P by Q form, we can call it as rational numbers. Okay, that is rational numbers. Okay, so what is irrational numbers? Which is opposite to rational numbers. This irrational numbers, we can't represent it in P by Q form or in fraction. That is irrational numbers. These all things you studied in smaller class itself. So just revise it. Okay. So the numbers which can't be represented as P by Q form or in fraction, which is called irrational number. Or if we represented it as in decimal form, its decimal digits, decimal place never terminates. Okay. It will repeat. Okay. We will discuss it again later. And it will not recurring. Okay. So that is irrational number. You know that the common examples of irrational number. What are the common examples of irrational numbers? Root 2, pi. Okay. These all are common examples for irrational numbers. So this rational and irrational number comes together and form real numbers. Okay. Clear? So we have natural numbers. If we include a 0 with the natural number, we get whole numbers. And we included some negative numbers with this whole numbers. Then we can call it as integers. And if these integers are both positive and negative integers, if we represented it as in p by q form or in fractional form, then we can call it as rational numbers. Okay, that is rational numbers, and the numbers which can't be represented in p by q form or in fraction, such numbers are irrational numbers. Okay, clear? So if there are any numbers which can't be represented in a number line, is there any? Yeah, you will study it on your 11th standard. Okay, it's imaginary numbers. Okay, so our first theorem in this chapter we studied is fundamental theorem of arithmetic. So what is simply how can we say what is fundamental theorem of arithmetic? There's a unique factorization theorem. That is a unique prime factorization theorem. I will explain it with an example. Okay, so if you want to factorize a number 12, we can split it into 6 into 2. 6 into 2 is 12. But here 2 is a prime number, so we can select 2. But 6 is not a prime number. So we have to factorize 6 again. Then how can we write 3 into 2? Okay, so 3 is a prime number and 2 is a prime number. So 12 can be 12. We know that 12 is a composite number, and we can factorize, prime factorize as 2 into 3 into 2. So this is a composite number, and we factorize it as a product of prime numbers. Okay, so this factorization is unique. Okay, this factorization is unique, and no other way is to express 12 as a product of prime. This is the only way to express. Okay, Arja, good evening. So this is the only way to represent this composite number 12 as a product of prime. So this factorization is unique. We can't express this factors or the 12, the composite number, as a product of prime factors in another way. So that's why fundamental theorem of arithmetic is also called unique factorization method, or it also called as unique prime factorization method. That is, if another example is 36. So we can represent 36 in different way. We can write it as 6 into 6, or okay. Second, okay. Here 18 into 2. In different ways we can represent 36. But in prime factorization, look at here. If we represented it as 18 into 2, then 2 is a prime number. So we don't want to further classify it. But 18 is a composite number. So again, factorize 18 as 2 into 9. Again, 2 is a prime factor, prime number, and 9 is not. So again, factorize 9 as 3 into 3. So finally, 3 is prime number. So what are the factors? 2 square into 3 square. Okay. So if we consider as in 6 into 6 as 36, 6 into 6. 6 is not a prime number, so further classified as 3 into 2. And again, this 6 is also 3 into 2. So look at here. 3 is a prime number, 2 is a prime number, again 3 is a prime number, 2 is a prime number. So what are the factors? 3 into 2 into 3 into 2. Again, 3 square into 2 square. Look at here. The answer is C. So this is a unique way. We can only got this prime factors only for this composite number. So that is basically fundamental theorem of arithmetic. Okay, that is every integer greater than 1 can be represented uniquely as a product of prime numbers up to the order of factors. That is fundamental theorem of arithmetic. Simply we can say every composite number, we can factorize it into prime numbers in a unique way. That's why it's called unique factorization theorem or unique prime factorization theorem. Okay. So moving to the next. So what are irrational numbers? We already tell that what are irrational numbers that cannot be expressed in form of P by Q or in factors. Okay, this can be represented as a factor, that is irrational numbers. And we can also tell that it is non-terminating. If we consider a decimal number 0.1026,576. If it never ends, if it a non-terminating decimal, if it never ends, it will continue, then this is an irrational number. Okay, or non-recurring decimal. What is recurring decimal? It has a definite pattern. If we take an example, if 0.010101, if it represent in this pattern 010101, that is recurring decimals. But irrational numbers are non-recurring. That is, it doesn't have a definite pattern. It will continue like different pattern. That is non-recurring decimal. So the irrational numbers, that is which cannot be expressed in P by Q form, that is in fraction, and also which is non-terminating and non-recurring decimals, that is irrational number. So in this chapter, we have to prove some numbers which is irrational. We have to prove the irrationality of that numbers. Okay, so this is the concept I covered in this chapter. Only 3 things are there. First, we have to aware about what is real number. That is a basic thing you already studied in your small classes. And the important thing that we had to study in this chapter is fundamental theorem of arithmetic. And we have to prove the irrationality of certain numbers. Okay. So here we prove irrationality of certain numbers by using a method that is called proof by contradiction. Proof by contradiction. That is proof by contradiction. So what is proof by contradiction? Suppose if you want to prove that root 2 is irrational, you have to prove that root 2 is irrational. But we can't directly prove that root 2 is irrational. So we prove it by contradiction. That is, we assume that root 2 is a rational number. Okay. First, we have to assume that a number, suppose root 2. Root 2 is a rational number. Then we have to prove that our assumption is wrong. Sorry. So if our assumption is wrong, what is our assumption? This is a rational number. So if our assumption is wrong, then what will it prove? That it's proved that the opposite to our assumption is right. That is a right, true statement. Okay, that is the method proof by contradiction. So in this chapter, we prove irrationality of all numbers through this contradiction method, which is simple. If we thinking about this, the proof, it seems like little difficult, but it is very simple. Okay. So shall we move to the questions? Okay. So some 1 mark questions. These are some simple questions. Okay. First 1 mark question is the greatest number which on dividing 1659 and 2036 leaves reminders 8 and 4 respectively. Then how can we find the answer? So look at the question. If greatest okay, Pratna. Is it visible, Pratna, now? Pratna? Okay, 1 second. Sorry, it got stuck. 1 second. Okay, sorry for the delay. Okay, we'll start again. Let me share my screen. Okay, let me share my screen. So, sorry for the delay, okay? So, we are moving to the questions. First, one more question. So, our first one more question is that we have to find the greatest number, which is divisible by the number, okay, 1649 and 2036, and which leaves a remainder 8 and 4 respectively. So, one thing you have to, okay, again. So, one thing you have to remember while doing the problem from this number system, if the question contain, okay, so if the question containing the words like highest, greatest, or largest, something like that, then you have to find the HCF of that two numbers. Okay, so you have to find the HCF of that two numbers. Okay, so if the question containing the words like what highest, greatest, or largest, something like that, then you have to find the HCF of that numbers. Okay. And if the question containing the words like minimum, lowest, or something like that, then what you have to find? Then you have to find the LCM of that number. Okay, LCM of that number. So that's the way we recognizing the problems related to HCF and LCM. So in this question, we have to find the greatest number which divides the number 1649 and 2036 and which leaves a remainder 8 and 4. Okay, so we have to find the greatest number. So it containing the word greatest. So if greatest, highest or largest come, then what we have to find? We have to find the HCF of that two numbers. Okay, we have to find the HCF of that two numbers. Okay. Okay. Sorry for the delay. Am I audible now? Is it visible, the PPT? Okay, sorry for the delay. Okay, so the first question is the greatest number which on dividing. We have to find a number. Okay, Pratna, good. So we have to find a greatest number which on dividing 1659 and 2036 leaves reminders 8 and 4 respectively. So look at the question. The question containing the word greatest. Okay. So the question containing the word greatest. That means if the question containing the word greatest, largest, or biggest, or something like that, then you have to find the HCF of that number. Okay, you have to find the HCF of that number. Yeah, Hiba, it's correct. So we have to find the HCF of that number. So how to find the HCF of that number? Also. So let us solve how to find the HCF of that number. What are those numbers? That is 2032 and 1651. So you can take the largest number as dividend and smallest number as divisor. Okay, so take the first question, answer of first question. 2032 is the largest number and 1000, take this as the dividend and 1651 as the divisor. Okay, so 2032 divides. Okay, so when we divide this, you can take 1651 into 1 as, because into 2 exceeds the number 2032. So we take into 1 as 1651. Subtracting it, we get 381. So check the remainder, which is not equal to 0. So then what we have to do? Take this divisor. Look at this divisor and the remainder. Divisor is greater than the remainder. So in next step, take this divisor as dividend and remainder as divisor. Okay. This method is included in the Euclid division lemma, but that portion is eliminated from your syllabus. Okay. So we take the remainder as the new divisor and the old divisor as new dividend. Okay. So we can take 381 into 4 as 1524. Subtract this, we get 127. Okay, again, which is the remainder is not equal to 0. So how can we take the check the remainder and the divisor. Then divisor is greater than the remainder. Look at this. 381 is greater than 127. So in next step, take this divisor. Okay, 381 as new dividend. That is 381. And new divisor is our remainder. Our remainder 127 is our new divisor. Okay, so 127 into 3 gives 381. So the remainder is 0. And whenever the remainder is 0, check the corresponding divisor, which is the HCF of the numbers 1651 and 2032. Okay. So how we get the 1651 and 2032? What are the numbers here? 1649 and 2036, right? So in the question, they said that which leaves a remainder. The first one leaves a remainder 8 and the second one leaves a remainder 4. Okay. That's why we get 1000. Okay. Okay. Clear? So moving to the next question. So 3 numbers are in the ratio 3:4:5 and their LCM is 2400. So what is their HCF? That is the question. So second question is 3 numbers are in ratio 3:4:5. Yeah, Abel, you can do factorization method also. This is a simple method. You can easily find it. That's why I prefer this method. Okay. You can also use factorization method. It's okay. Any method you can do. Okay. For larger number, I think this method is more preferable. If you are more good with factorization, then you can do factorization method also. Okay. So the second question. So 3 numbers are in the ratio. What is the ratio? 3:4:5. So which is in the ratio 3:4:5. And they given that LCM of these numbers are 1200. Okay. We have to find the HCF. Okay. We have to find the HCF. Okay. Let's take HCF is equal to X. Okay. HCF is equal to X. Then what will be the numbers? Then the numbers will be, okay, the numbers will be 3x, 4x, and 5x. Okay. These are the numbers. Okay. So what is the LCM of these numbers? LCM of 3x, 4x, and 5x. What is the LCM of these numbers? That is 3 into 4 into 5 into x, right? So this is the LCM of these numbers, 3x, 4x, and 5x. And which is equal to 60x. Okay. In the question, it is given that LCM is 1200. That is, this 60x is equal to 1200. Okay. So what is x? That is 1200 divided by 60. Okay. That is equal to 20. So the HCF, what is x? We take x as HCF. So the HCF is equal to 20. Okay, clear? So moving to the next question. Last question from 1 mark questions. That is, if A, B, and C are 3 numbers which is A, B, and C, such that LCM of A and B is B and B and C is C, then what is the LCM of A, B, and C? That is a question. So, what are the numbers here? A, B, and C. Okay, A, B, and C are the numbers, and LCM of A and B. LCM of A and B is B. Okay. So LCM of A and B is B. Okay, Acha, I will show it again. So the question is, look at the question. There are three numbers, which is A, B, and C. And LCM of, first is LCM of A and B is B. That is, you take two numbers, A and B, then its LCM is B. And then LCM of B and C is C. That is, we take the numbers B and C, we get the answer LCM as C. Then we have to find the LCM of these three numbers A, B, and C. That's what we want to find. Okay. So, LCM of A and B is B. What it means? LCM of A and B is B. That means this B, that is, this B is the multiple of what? Multiple of A. Is it? That is LCM of, if LCM of A and B is B, then B is the multiple of A. And second thing is LCM of B and C is C, right? B and C is C. That is, C is the multiple of B. Is it? We already said that B is the multiple of A. And now we said that C is the multiple of B. If C is the multiple of B and B is the multiple of A, then we can analyze that. That is, C is the multiple of A also, right? C is the multiple of A also. So, C is the multiple of both groups, both A and B and C. So, now we can set that LCM of A, B, and C, which is, what is the number? Which is C, because C is the multiple of B and C is the multiple of A also. So, LCM of A, B, and C is C. Okay. So, it's given three numbers and they given that LCM of A and B is B. That means B is the multiple of A. And B and C is C. That is, C is the multiple of B. If C is the multiple of B, we already said that B is the multiple of A. So, C is the multiple of A also. So, C is the multiple of B and A. That's why LCM of A, B, and C is C. Okay. Clear? So, moving to the 2-mark questions. So, first question. There's a circular path around a sports field. Sonia takes 18 minutes to drive on one round of the field, while Ravi takes 12 minutes of the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes they will meet again at the starting point? So what will we do in this question? So if you get a question like that, something together, they arrived together or simultaneously or meeting at the same time, same point, something like that. In most of the case, we have to find the LCM of the numbers. Okay, LCM of the numbers. Okay, or if the question is something like classification, or distribution or stacking our books or arrangements, something which included arrangements, then we have to find the HCF of that numbers. So in the first question, which we want to find the time both arrive at the same, meet at the starting point again. Okay, together, they meet together. That's why we want to find the LCM of the numbers. Okay, so let's check the question. If the question containing something like together, simultaneously, or some that ideas, then you have to take the LCM of those numbers. Okay, so look at the question again. There's a circular path around a sports field. Okay, so there's a sports field and here is a circular path. Okay, there is a circular path around the sports field. Okay, Shiza, good. So there is a circular path around the sports field and both Sonia and Ravi drives that around the field, and Sonia takes 18 minutes to drive one round, and Sonia takes 18 minutes and Ravi takes 12 minutes. Okay, and both start at same time, same point, and going in the same direction. So they meet at the same point again, which we'll find by taking the LCM of 18 and 12. So we can take the LCM of 18 and 12. Okay, let's factorize 18, 9, okay, 3, 3, and 12, 2, 6, 3, 2. Okay, so this is 2 into 3 square, and this is 3 into 2 square. We should take the fraction with the highest power. So that is 3 square into 2 square. So the LCM of 18 and 12 is 3 square into 2 square. That is 9 into 4, which is equal to 36 minutes. At 36 minutes, they meet together. Okay, we can find it using another method also. If Sonia takes 18 minutes to cover one circle and Ravi takes 12 minutes to cover one circle. Okay, then at first circle, they take 18 minutes and 12 minutes on the first circle. On the second circle, Sonia takes again 18 minutes. That is 18 plus 18, 18 into 2. Okay, that is 36 minutes. On the second round, 36 minutes, Sonia takes to cover 2 rounds. And Ravi, 12 plus 12, 24 minutes to take 2 rounds. And 3 rounds, considering 3 rounds, then add an 18 minute to this 36 again for Sonia and get 54 minutes. And for Ravi, add a 12 minute to this 24, get 36. Look at here. Here, at 36th minute, they met together. Okay. So, they meet at same point again at the time is equal to 36 minutes. Okay, clear? So moving to the next question. 3 sets of English, Hindi, Maths books have to stack in such a way that all the books are stored topic-wise and the height of each stack is same. The number of English book is 96, number of Hindi books is 240, and number of Maths books is 336. Assume that books are on the same thickness. Determine the number of stacks of English, Hindi, and Maths books. So this is an arrangement, right? So I already tell you, for arrangements, what we have to find? We have to find HCF. Okay. For arrangements, we have to find HCF. So we have to find the HCF of 96, 240, and 336. So if the question containing some arrangements or distributions, then we have to find the HCF of those numbers. So first is 96 divided by 2, get 48. Again, divided by 2, 24. 2 is 12. 2 is 6 and 3. Next is 240. Is 120, 260, 30, 15. Okay. And 336, 168, 84. There is 42. 21, 7 3s are 21. Okay. So we can arrange it as 2 raised to 5 into 3 and 240 as 2 raised to 4 into 5 into 3 and 2 raised to 4 into 3 into 7. Okay. So what is the HCF of 96? 240, 336. The lowest power from and the common factor taking first is 2 raised to 4 and another common factor is 3 and lowest power is 1. So 3 and the answer is 48. Okay, the answer is 48. Clear? Okay, Chisa, good. Okay, good. Good, Chisa. So the answer is 48. The only thing you have to remember that if the question containing together simultaneously or something like that, you should take the LCM of those numbers, then you get the answer. And if the question, okay, Acha, good. If the question containing some arrangements, classification, distribution, or something like that, then you have to find the HCF of those numbers. And also, if the question containing highest, greatest, or something like that, then you have to find the HCF of those numbers. And if a minimum, shortest, smallest, something like that, then you have to find the LCM of those numbers. Okay. If that is clear, then you will able to do all problems related to LCM and HCF. Okay. Then going to the 3-mark question. 2 tankers containing 850 liters and 680 liters of petrol, respectively. Find the maximum capacity of the container. So look at here, maximum capacity. So from this word itself, we can make it clear that we have to find HCF. That is maximum means HCF. Okay, maximum. When we solve maximum, don't look back. Then find HCF of these 2 numbers, 850 and 680. So you can find the maximum capacity of a container. Okay. So this is a big number. So you can take the first method I have told in Euclid division lemma. So maximum means HCF of 850 and 680. Okay, you should take the HCF of 850 and 680. So we can take rather than from the factorization method, it is easy to find it using Euclid division lemma. Okay, so you can take this is the largest number 850 as dividend. So 850 as dividend and 680 as divisor. Okay, 680, you should take 680 into 1 because 680 into 2 exceeds 850. That's why I take 680 into 1 is equal to 680 and subtracting we get 170 and which is not equal to 0. If remainder is equal to 0, then you can stop there. If remainder is not equal to 0, then look at the divisor and the remainder. Here divisor is greater than remainder. Okay. So take divisor as next dividend and remainder as next divisor. So then take 170 into 4. 170 into 4 is 680. So the remainder is equal to 0. So the corresponding divisor is HCF. This is the simplest method. Okay. You can follow this method. This is very easy to find HCF. Okay. Okay. Okay, Archa. So 170 is the maximum. So therefore, the maximum capacity of a container is equal to 170 liters. Simple, right? Okay. So moving to the next question. Explain why the number 7 into 11 into 13 plus 13. First set of number is 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. We have to prove these numbers are composite numbers. Okay, so we can write the first set of number. That is 7 into 11 into 13 plus 13. So here it divided by a plus sign, separated by a plus sign. So this containing two terms, right? This is a term, first term, and this is the second term. So we can take 13 as common from these two terms. Okay. So 13 into 7 into 11 plus 1. Okay. So 7 into 11, 77 plus 1, that is 78. That is 13 into 78. And factorize 78. 78 divided by 2, that is 39. So 39, the table of 13. So 13 into 3 is 39. So we can factorize it as 2 into 13 into 3. Okay, 2 into 13 into 3. So we can write it as 13 into 3 into 2 into 30. Okay, the factors of 78. So these are the factors of this composite number, which is given in the question. Okay, this number. So these are the factors. So look at the factors. It has more than 2 factors, right? It has more than 2 factors. What is prime numbers? What is prime numbers? Prime numbers only have 2 factors. Is it? 1 and the number itself. But look at here. when we factorize this number, we get a factor 13, 3, 2. So it has more than 2 factors, right? More than 2 factors. So this is not a prime number. So this is a composite number. So this is a composite number. Composite number. We proved. Okay. So moving to the next, which is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Here also there are 2 terms. We can take 5 as common. Then 7 into 6 into 4 into 3 into 2 plus 1. So which is equal to 5 into 1009 plus 1. Okay. Plus 1. So here we can take only the factors. Factors are 5 into 10 plus 1. 1009 into 1. Okay. Here also it has more than 2 factors because the factors are 5, 1009 and 1. There are more than 2 factors. So this is also a composite number. Here also it has more than 2 factors. So this is a composite number. Okay. Composite number. Okay. So moving to the next question. Which are 4 mark questions. Prove that the followings are irrational. We have to prove the irrationality of those numbers. So I already tell you how to prove the irrationality of some numbers. That is, we proved it through the process called the proof by contradiction. So first we have to prove the given number is rational, and then we have to prove that our assumption is wrong. Then we can automatically prove that the original statement is true. Okay. So the first question is we have to prove irrationality of the number 6 plus root 2. So the first one is 6 plus root 2. So first we have to assume that 6 plus root 2 is rational. Just assume 6 plus root 2 is rational. If it is rational, we can express as that is 6 plus root 2. If it is rational, then we can express it as 6 plus root 2 is equal to A by B. Rational number is, we can represent it in P by Q form, fractional form, is it? So we can represent it in A by B form. And here A and B are co-prime and B is not equal to 0. Okay. So 6 plus root 2 is A by B and root 2 is equal to A by B minus 6. Okay. Which is equal to A minus 6B by B. Okay. So root 2 is equal to A minus 6B by B. So look at the RHS. which is a minus 6b and b. These are integers, right? Are integers. Okay, integers, and therefore a minus 6b by b is rational. Okay, this is rational number. But we know that what we know, root 2 is irrational. Okay, root 2 is an irrational number. So if root 2 is an irrational number, then our LHS is not equal to RHS, because RHS, a minus 6b, b are integers, and which is an rational number. But we know that root 2 is irrational. So LHS is not equal to RHS. So our assumption is wrong. Therefore, our assumption is wrong. Okay, our assumption is wrong. And this contradicts the fact that root 2 is irrational. Simple, right? So we proved that root 2 is irrational. And which is next questions are also similar questions. 3 plus 2 root 5. Second question is 3 plus 2 root 5. 3 plus 2 root 5. We already know that root 5 is irrational. And first, again, assume that what we have to assume, 3 plus 2 root 5 is rational. That is 3 plus 2 root 5 is equal to a by b, and from this root 5 is equal to a minus 3b by 2b. A minus 3b by 2. So here also a minus 3b, 2b are integers, and therefore a minus 3b by 2b is rational. But root 5 is irrational. Therefore, LHS is not equal to RHS. Our assumption is wrong. Is wrong. And this contradicts that. This contradicts that 3 plus 2 root 5 is irrational. Okay, simple. If the question is something like a fraction, like 1 by root 2, then also you can use this method. Okay, so a fourth question, 1 by root 2. So just assume 1 by root 2 is rational. So 1 by root 2 is equal to a by b. Okay, and root 2 is equal to b by a, and b and a are integers. integers. Therefore, b by a is rational. But we know that root 2 is irrational. So again, LHS is not equal to RHS. So our assumption is wrong. Assumption is wrong. That contradicts. That contradicts that 1 by root 2 is irrational. Okay? Clear? And try to solve this question 5 minus root 3 by yourself. Okay? 5 minus root 3 by yourself. It's a similar question. First assume 5 minus root 3 is a rational number. Then we can take 5 minus root 3 is equal to a by b, and root 3 is equal to 5b minus a by b. Then 5b minus a, b are integers, and that's why 5b minus a by b is a rational number. But we know that root 3 is an irrational number. So LHS is not equal to RHS. Okay, so our assumption is wrong. If our assumption is wrong, then what is right? Our first statement, that is 5 minus root 3 is irrational, is an irrational number. Okay, the proof is very simple. If you study to prove one number, then you can prove every number. Okay, so it's very simple. The same method continues for every number. Okay, so that's it. So today we studied about real numbers. So what is real numbers? It constitutes a union of rational and irrational numbers. That simply we can say a number that can be represented on a number line. And fundamental theorem, we already said that it is a unique factorization method, a unique factorization theorem. Okay, that is every integer that greater than 1 can be represented uniquely. Okay, a unique method as a product of prime numbers. That is simply a fundamental theorem of arithmetic. And finally, we proved the irrationality of some numbers. That's a method using proof by contradiction. Okay, so do you have any doubt with these questions or the concepts or anything? We have so many questions related to this topic, and these are some like common questions. Okay, answer good. If you have any doubt, you can ask me on the next revision classes or all. Okay, so thank you all. Good night.